Okay, so you've now got your results. So here's my table that I've produced, and as you can see, my average titration for the two actual titrations that I've done is 27.0. So this is the value I'm going to use. And don't forget, in the last video I did say that the rough titration is literally there just to tell us where we should be aiming for when we do our final titrations. It is not included in the average. So the balanced equation for our acid-base titration that we've performed is as shown. It's important to note at this point that it's a 1-to-1 ratio, so 1 mole of HCl will react with 1 mole of NaOH. Now the whole purpose of an acid-base titration using volumes of titration is to work out the concentration of an unknown. In this case, the unknown concentration is for sodium hydroxide. We can use the triangle to work out concentration as shown, where N stands for number of moles, C equals concentration in moles per decimetre cubed, and V equals volume in decimetres cubed. The next step is to write down what information we've got for each of our reagents. The volume of sodium hydroxide pipetted was 25 centimetres cubed. The volume of HCl from the average titer was 27.0. The concentration of the hydrochloric acid off the bottle was 0.1 moles per decimetre cubed. We don't know the concentration of the sodium hydroxide yet. We've now got two pieces of information about the hydrochloric acid, and we can use the triangle to work out the number of moles. So the number of moles of hydrochloric acid using the triangle would be concentration times by volume. The concentration is 0.1 and the volume is 27.0. However, as for the volume units, it has to be divided by 1,000 because that value here, 27.0, is in centimetres cubed, and we need to record it as decimetres cubed. The answer to this is 0.0027 moles. Now we know how many moles of HCl were actually reacting with the sodium hydroxide, and because this is a 1-to-1 ratio, we can therefore say that 1 mole of HCl will react with 1 mole of sodium hydroxide. However, we didn't have 1 mole, we had 0.0027, so therefore we can say that there are 0.0027 moles of sodium hydroxide reacting with the hydrochloric acid. Now what we need to do is to use the triangle to calculate the concentration of the sodium hydroxide. Concentration of NaOH is equal to the number of moles divided by volume. The number of moles, as we've calculated, is 0.0027 divided by volume, which is 25.0, but don't forget that has to be divided by 1,000 because it has to be in decimetres cubed. And once you've calculated that, it comes out as 0.108, and the units for that will be moles per decimetres cubed. So this tells us that the concentration of the sodium hydroxide here is actually slightly higher than the concentration of the hydrochloric acid. And that kind of makes sense because actually you need a larger volume of the HCl titrated in order to neutralise that sodium hydroxide, which is of a slightly higher concentration. Now what you need to do is to insert your figures for the titration of your hydrochloric acid and the volume that you pipetted for your sodium hydroxide in order to work out the concentration of your sodium hydroxide from your own titration.